It's often the case that a lot of programming problems can be solved many ways. A developer might find one solution for a problem while another may have a different fix to solve the same problem. This creates a need for consistent approaches to fix issues, consistent patterns that avoid issues. And that's what this course is all about. Hi, I'm Ronald Adolph, and welcome to C# Design Patterns. Software design patterns define solutions to problems programmers often find in real-world applications. In this course, I'll cover the origins of some well-known patterns created by a group of computer scientists called the Gang of Four, as well as the three categories their patterns fall into: creational, structural, and behavioral. Then I'll jump right into describing and demonstrating a few patterns in C#. While I won't cover all 23 Gang of Four patterns, I will discuss factory method, abstract factory, decorator, observer, singleton, and iterator. Finally, I'll cover a couple of non-Gang of Four patterns that are often used in .NET, like repository and unit of work. Implementing design patterns in C# keeps code clean, concise, easy to maintain, and it adheres to the solid principles of object-oriented programming. So let's go ahead and get it started. For this course, I'm assuming that you're already comfortable coding with object-oriented programming. In particular, you should be familiar with C# language and implementing interfaces, the three pillars of object-oriented programming, such as abstraction, inheritance, and polymorphism, solid principles, the difference between composition and inheritance, fundamentals of class diagrams, and navigating through Visual Studio. If you're not familiar with some of these, or if you have any questions while watching, I'd recommend checking out C# Essential Training and Test-Driven Development. If you have access to the exercise files, you can follow along with the code examples that I'll be working with in this course. Within these files, you'll find a folder for each chapter of the course. And within each chapter, you'll find subfolders for each video. And within those folders, you'll see that there is a start and a finish state. If you want to follow along, open up the solutions in the start folder. And when you're done with the video, you're welcome to compare your code with what I have in the finish folder. If there's not a start and a finish state, for example, in chapter 3, that's simply because the video will be reviewing existing code. A design pattern is a general, reusable solution to commonly occurring software problems. It's not a finished specification that can be transformed directly into code. Instead, think of it as a blueprint for a solution. Design patterns make it easier for programmers to produce high-level solutions without getting bogged down with implementation details. When done right, these patterns lead to software solutions that are easily understandable, testable, and maintainable. Maintainability is one of the most important benefits because it anticipates potential change to the software, and because of this, makes it easier to update code when major changes are needed. Some well-known patterns programmers use today were first outlined in the book Design Patterns: Elements of Reusable Object-Oriented Software. This book was written by 4 researchers: Eric Gama, Richard Helm, Ralph Johnson, and John Velicides, commonly called the Gang of Four. Pretty cool name. This book fundamentally changed the way programmers think about writing code. The Gang of Four covered 23 patterns, which are now generally considered the foundation for all other patterns. So you might ask yourself, do I really need to think about design patterns? I already write code that's easily maintainable. Also, my code works. Well, the thing is, you want to keep in mind that just because you don't need it now doesn't mean that you won't need it in the future, or another developer might not benefit from it. Sure, if it's a program that's just 20 lines of code, a pattern might be an overkill. But for larger scale applications, you want to leverage design patterns when it's appropriate, because besides the fact that they provide solutions and make your code maintainable, there's two other major benefits. One is that it provides a shared vocabulary. That is, they make it easy to explain code, rather than saying, can you write some code to let you set up or alter an object at runtime by wrapping them in some class and leaving the object intact without modification? Instead of saying all that, you could just say, hey, could you just use the decorator pattern? Another benefit that I like to say is that it provides academic motivation. That is, those that learn to implement design patterns really well and know the benefits of them, those individuals will be the ones that might end up developing new patterns for issues that currently aren't addressed by existing design patterns. Don't sell yourself short. Somebody had to create design patterns in the very beginning, and new ones might be needed in the future. There are three categories in design patterns: creational, structural, and behavioral. Creational patterns provide a way to make objects while hiding the creation logic, rather than instantiating objects directly. In short, they deal with object creation mechanisms. Structural patterns are all about class and object composition. This design pattern tends to ease the design by identifying a simple way to realize relationships between entities. Behavioral patterns are specifically concerned with communication between objects. That is, how objects communicate with each other. There are 6 designs that fall under creational patterns: abstract factory, builder, factory method, object pool, prototype, singleton. In this course, we'll explore 3: abstract factory, the factory method, and singleton. All have to do with instantiating objects. 7 designs fall under structural patterns: adapter, bridge, composite, decorator, facade, flyweight, and proxy. We'll be exploring the decorator and how it adds functionality to objects dynamically, and how composition plays a major role. Lastly, there's the behavioral category, which consists of 11 patterns: chain of responsibility, command, interpreter, iterator, mediator, memento, observer, state, strategy, template method, and visitor. Here we'll explore iterator and observer to understand how objects communicate with each other. The Gang of 4 describes the factory pattern as defining an interface for creating an object, but lets subclasses decide which class to instantiate. Factory method lets a class defer instantiation to subclasses. So what does that really mean? This pattern is simply about requesting objects that are created behind the scenes and having the correct type of the object returned to you. We're going to create an example of a program for a credit union that returns savings account information depending on the account number passed in, so it returns the correct type of savings account. But let's first look at the factory method class diagram. We have a product. The product defines the interface of objects the factory method creates. For our example that we're going to do, it's going to be an iSavings account. It's going to be an abstraction of an interface. Right below it is the concrete product, and that implements the product interface. For us, it's going to be City Savings Account and National Savings Account. Next to product, we have another abstraction, creator. The creator declares the factory method, which returns an object of type product. So for us, that's going to be our factory, and we're going to be calling that iCredit Union Factory. Right below that is the concrete creator, and that overrides the factory method to return an instance of a concrete product. For us, it's going to be a savings account factory. Now, without any further ado, let's go on and write some code. Let's assume 2 credit unions merge, and now they share an API that pulls account information from each company that merged. One called City Credit Union, and the other National Credit Union. What it does is it returns a savings account object depending on the account number passed in. We're going to demo this. So go ahead and open up from your exercise folder the solution for factory method. We're going to step through this one by
Is
one.
the web service secured?
The first thing
And
that
if
I
so,
did
what do you need
is
for
I
authentication?
created
Are a
an
simple
abstract
username
product
and password
that's a class
sufficient?
called
Or
iSavings
does
account.
some sort of security
And all I
token
did
get
is
passed
add
back
in
and
one
forth?
property in there
And when
for
data is
balance.
returned from the web service,
Following that, I
what
created
form will it
two
be in?
concrete
will it
products.
be in XML,
One called
JSON,
Savings
or some
Account
other
that
format?
inherits from
Are there
iSavings
particular
account.
field names and data
And
types
within
that
the
you need to know
constructor,
about?
I
And are
defined
you
a
always
value
getting
of
back all of the
$5,000
data,
for
or
the
is there some
balance.
sort of data paging mechanism?
Right below it is a
All
second
of these
concrete
taken
product,
together are the
and
web
it's for
services
National
API.
Savings Account. And
For
likewise, it
developers,
also
the
inherits
idea
from
of an API is
iSavings
commonplace,
account.
whether it's a client-side library for a
Similarly, within the
particular
constructor,
language,
this time
such
I
as
defined
Java,
the
Ruby,
balance
or
as
Python, or
$2,000.
a description of how to perform
Next,
actions
I
on and
create
get data from a
the
remote
Create,
server.
which is an interface
An
called
API and
iCredit
its
Union
associated
Factory,
documentation
and it
are
returns a
critical
type
to
of
the developer's
iSavings
success.
account for
As you'll see
an
throughout
operation
this
called
course,
Get
you can
Savings
only use
Account,
web
which
services
takes in
if
an
you know how
account
to
number.
speak their language.
Next is
And
the
finally,
concrete
there's a
creator,
big difference between
which is
knowing how
called
to talk to a
Savings
web
Account
service
Factory,
and knowing
and
how
it
it's
implements
working in the server
iCredit
environment.
Union Factory.
When you send a
And
request to
within
the
here,
web service, you'll
this
need
is
to know
the
whether to use
essence
SOAP
of
or
the
JSON,
factory method, because it
HTTP
contains
put or
the
GET
logic that
requests, and
determines
so on.
what
But you
type
usually
is
don't
going
need
to
to
be
know what
sent
programming
back.
language,
So
database,
if
or other
the
technologies
account
are
number
being used in the
contains
server
a city,
environment.
it's going to
A
return
web service
the
hides its
savings
complexity
account,
behind
a
the
new
wall
instance
of the
of
web.
that. And keep in mind
It
that
doesn't
this
matter whether the web
inherits
service
from
is managed by
iSavings
PHP,
account, which is a type
ASP.NET,
that's
or
mentioned
Node.js.
at the top of this
As long
method
as you
here.
send the request in the right format,
Likewise, if the
get
term
back the
inside the
expected
account number
responses,
is
you'll be able
national,
to call the
then it
web
will
service
return the
from
national
your
savings
client-side
account.
application.
If neither of those
And if you're
exist,
building web
then
services,
an argument
you
exception
shouldn't
will
have
be
to care
thrown,
what sort of clients are sending
indicating
the
invalid
requests.
account number.
They could be coming from
And
desktop,
that is
web,
about
mobile,
it.
or
The very
embedded
last thing
applications.
that we
They
did
could be running on a
is
computer,
in
a
our
phone,
client,
a tablet, or
which
an internet-connected
executes the
refrigerator.
program.
And of course,
For the very
they
first
can be
line,
loaded in any
I
supported
created an
programming
instance
language.
of a savings account
As long
factory,
as they ask their
and I
questions correctly,
set it as a type of
your web service
iCredit
should be
Union
able to
factory.
send
Now,
back
for
the
large
expected
scale
responses.
programs, we would
Web
probably
services
use
are
some
therefore
dependency
the
injection,
great
but that would be beyond the
decouplers of
scope
modern
of this
computing.
particular exercise.
The client doesn't understand how
Following
the server works,
this line,
and
we
vice
have
versa.
two
Each
lines
does what it
that
does
call
well,
get
and they
savings
work
account,
together
passing in
through
account
a shared
numbers.
vocabulary.
One is going to receive the savings account for city, and the other for national. So
According to one
the very
source,
last thing is to
the
write
term
out something
web
to the
service was
council
first uttered
that's
by
going
Bill
to
Gates
reference
at a
the
software
balance of
conference in
city
July
and the
2000.
balance in
But the
national
concept
account.
of two computers
Let's go ahead
communicating with
and
each other
build.
to share business information,
And I will hold
and
the
speaking
control
in a
key
shared
down and
vocabulary
hit the
with a
F5 key
strongly
to
defined set of
run
protocols
the
wasn't
program.
new.
That
The
using
concept
those
has
two
been around
combinations
since
will
before the
halt
internet was
the
invented.
console so that we can
One of
actually
the
read the
earliest
output.
implementations of web
My
service
city
style
balance is
architectures is
$5,000
known as
and national
EDI,
balance is
or
$2,000.
electronic data interchange.
And that is exactly the
EDI
value
was
that you are
documented in
expecting.
1996 by
Return
the
the
National
appropriate
Institute of
value
Standards and
depending
Technology
on the
as
property
the computer
that
to
was
computer interchange of
referenced.
strictly
The main
formatted
thing to
messages
get out of
that
this
represent
is that
documents other
the
than
factory
monetary
method
instruments.
creates the correct
In
type
other words,
of objects
EDI
needed
was
behind the
designed to go
scene,
beyond
like in my
financial
case, returning
transactions
the correct savings
and enabled
account.
the movement of
The
data
logic
back
is
and forth
abstracted
over the
away
internet.
from the client.
It was
All
originally
I
designed
did
for
is
large-scale
pass in an
e-commerce,
account number,
but it's also
and it
used
knew
for
whether
all
or not
sorts of
to
business
return
transactions,
a
including
city account
invoicing and
or a
payments,
national account.
inventory management, shipping and freight, and much more. EDI
The Gang
is
report
tied
describes the
directly to
abstract
the internet.
factory pattern
In
as
fact, the
providing an
earliest
interface for
versions
creating
communicated
families
over
of related
telex,
or dependent
starting in the
objects without
1960s,
specifying their
and then
concrete classes.
bidirectional modems.
So we already
communicating
talked about
over
what
phone
factory
lines in
methods
the
are and how
1970s.
they're factories
FTP, or file
responsible
transfer
for
protocol,
creating objects.
in the 1970s.
Well, you can think of the
and
abstract
VANs,
factory
or
pattern as a
value-added
factory
networks,
for creating
hosted
factories.
services
It's
that
like the
act as
factory method pattern,
intermediaries
but
with
everything is
business partners.
encapsulated.
But
It's a
as
higher
the
level of
internet gained
abstraction
momentum,
using
the
interfaces and
EDI
abstract
standard was
classes.
adapted to the world
Let's
of
take a look at this
increasingly
class
connected
diagram.
business computers.
Let's start on the
In the
left-hand
early
side
1990s,
with the
a
abstract
new standard
factory.
emerged known
That
as
simply
RPC,
declares an
or
interface for
remote
operations that
procedure call,
create abstract
based on
product
another
objects.
standard known Someone
And right
has a
below it
distributed
is a concrete
computing
factory,
environment,
which
or
implements
VC.
operations to create
RPC
concrete
systems
product
allow client
objects.
computers to
Now on
call
the right-hand
functions
side we have
or
our
subroutines
products, abstract product
hosted
A
by
and
remote
abstract
computers,
product B. Those
using
declare an
syntax as
interface
similar
for
as
a type
possible
of product
to the code
object.
they might use
And
locally.
below those, are their
RPC
concrete
had its
products,
roots in the
which
world of
defines a
Unix,
product
but
object
Microsoft
to be
quickly
created
followed up
by
with
the
their own
corresponding
flavor,
concrete
known as
factory.
MS-RPC.
On the upper right-hand
That
side,
was followed by
we have our
Microsoft's
client. And what's
COM
important to point out
architecture.
there is
COM
that they
stands for
point to the
Common Object
abstraction,
Model,
the abstract
and
factory,
OLE
and the
stands
abstract
for
product
Object
A
Linking and
and
Embedding.
B.
And the
To put this
related
more in real
DCOM,
terms, let's
or
continue with
Distributed
our
Component
banking
Object
thing.
Model.
Say we have two
These
credit
were all
unions.
built on the
They can
foundation
both
of
be
BCE
considered our
and
factory.
RPC.
Each have a savings account and a
Also
loans
in the early
account.
1990s,
Those can be the
a competing
products.
standard named
On the upper
Corba
left-hand side
for
here, you see
Common
that our
Object
credit union
Request Broker
factory
Architecture
takes place
emerged.
as the abstract
A
factory.
Corba-based
And below
program
it, the
from any
concrete
vendor
factories
on
are
almost
City
any
Credit Union
computer,
Factory
operating
and
system,
National Credit Union
programming
Factory.
language or
Below
network
those
could
are the
interoperate with another
implementations.
Corba-based
On the
program.
right-hand side, our products
Corba was
are
powerful but
iLoan account
complex.
and
And in the
iSavings account. Below
mid-1990s,
them
a number
are
of
their
efforts were
concrete
made to
implementation
simplify
of
the
the products.
technology.
So let's go ahead and take a look
RMI,
at some
or
of the
Remote
code
Method
and see how this all
Identification,
plays out.
was an interface designed to communicate over the Internet Interorg Protocol,
I have a solution
or
opened up that
IIOP.
demonstrates an abstract
And so this
factory.
very busy
You can
period
find
of
it
remote
in your
computing,
exercise folder
starting
for this
roughly in
chapter.
1991,
I'm going to walk
go
through
into
it.
1996,
And in this video,
saw the
I'd like to focus
emergence
on the
and
code
active use of
written
nearly a
leading
dozen
up to
different
writing
standards,
the first
each
factory,
with their own
City
protocols,
Credit Union,
message
and
formats,
its products.
and supported programming
So
languages
if we
and
flip
operating
back
systems.
to our class
But they all had
diagram,
in common
on the bottom
a level
left-hand
of
corner,
complexity
you'll see
that made them
City
difficult
Credit
to get
Union
started with
Factory.
and difficult to use.
We're going to show the code
Then
that
in
leads up
1998,
to
the
creating
world of web
that
services was
particular
revolutionized
class.
with the
Above it
introduction
is
of
abstraction,
XML, or
iCredit
Extensible
Union
Markup
Factory.
Language.
We'll show the
XML
code
was
that
derived from
reflects
another
that.
markup language
In
called
addition to,
MGML,
on the
standing
right-hand
for
side
Standard
is
Generalized
products,
Markup Language,
iLoan account,
and its goals were
iSavings
simplicity,
account, and
readability,
its
and
concrete
generality.
products.
Readability
City
means
loan
that
account
XML
and City
is readable
savings
by both
account.
humans
So it's all
and
about
machines.
the City
And
product and
generality
City factory
means
right
that
now.
it can be adapted to
So
multiple
I started
purposes.
off creating an
Unlike
abstract
EDI,
class.
or the
That's
binary
the
format
iCredit
of some other
Union
systems,
Factory.
XML is
This
plain text.
factory has a
And
couple
when
of
formatted as
operations.
a hierarchical
Create
set of
a savings
nested
account
tags,
and
it's
create
easy to
a loan
read with
account.
human eyes.
And each of them are going
XML
to
was
be of a
intended
type
for multiple
of
uses.
iSavings
One
account
variant is
for creating savings account
XHTML,
and
a more
iLoan
structured
account.
version of HTML
Next is
that's
creating
recognized
abstractions
by
of
all
products.
modern web browsers.
And we have an
But
interface for
XML was
iLoan
also
account
ideal in many
and
ways for data
iSavings
exchange.
account.
Because
And
it
that
has
really
strict
consists
formatting
of
rules,
the major
you can
higher-level
easily
abstractions.
validate whether a
Now if we can
particular
navigate
XML
to the
snippet
City Credit
properly
Union project
represents
and
the
open up
respective
the
data.
Credit Union
As
Factory
a
file,
result, it
you'll see
quickly
what we
became one
have
of the
is
most
the
common formats
concrete
for
products.
web service
We have
messages.
the
Some
City
standards
Savings account
emerged.
and
First,
City
XML
Loan
RPC,
account.
a simple
Both of
set of
them
rules that define a set of
implement
data
an
types
interface.
that could be
And
encoded
the
in
first one,
XML
City
format
Savings
for
account,
transmission
implements
over the web.
iSavings account.
Atom
And basically what we're
RSS
going
are
to
some
be
of the
doing
best-known
for
XML-based
each of
languages
these
used
is
in today's web
returning a
services.
string to the console that says,
But there are literally
for this
thousands of
particular
different
case,
XML languages
return City
designed to
Savings
represent
account.
all
And for
sorts
the
of
City
data models.
Loan account, we'll be
A
returning
couple
a
of
string
years after
indicating
XML
that
had been
it's the
standardized,
account that we're
SOAP
in.
was introduced.
In our class
And
diagram,
it revolutionized
this
the
reflects
use of
on the
web
right-hand
services.
side the concrete
SOAP is an
implementations
XML
for City Loan
language
account and
that
City
was based
Savings
on the
account.
XML RPC standard.
As we scroll
but took it
down,
much further. As
the
you'll
next
see in
thing
a
we
chapter
have
of this course
is
that's
our
dedicated to
concrete
SOAP.
factory. This is our
This
first
format became
factory.
the foundation
City
of
Credit
a whole
Union
set of web service
Factory, which
technologies
implements
known
iCredit
collectively
Union
as
Factory.
WS
And this is where we
or web services
override our
everything.
implementations
And the most
actually
recent advance in web
return
service
the
messaging
types that
formats
are
is
requested.
JSON,
And it would
standing
either
for
be
JavaScript
City Loan
Object
account
Notation.
if we're invoking
JSON was
create loan
introduced
account,
in the early
or
2000s, but
returning
has
City
especially
Savings
gained
account
momentum in the
if
past
invoking
5 years.
create
As the
savings
mobile
account.
revolution has
Now let's
changed
go
the
ahead
way we
and take
think
a
of
look
computing.
at the code that leads
Like
up to our
XML,
second factory.
JSON is text-based and human-readable, but it has less
We're not going to cover
decorative
the code
notation and
that
therefore can be
leads to
much
creating
smaller
our
than
second
XML.
factory. So if
In
we
the
were to
world of
flip
the
back
web,
to our
smaller
class
means
diagram,
faster,
on the right-hand
since it
side,
takes less
under
bandwidth
iLoan
to send
account,
and receive
you'll
messages.
see National Loan
On mobile
account.
devices,
And right under
cell
iSavings
phones,
account,
tablets,
National
smaller
Savings account.
means less
Those are the
storage
concrete
and computing
implementations
requirements,
of the
and
product.
less
So
bandwidth
So we're going to
to
show the
transmit
code
messages over
that
the
creates
web.
that. And on the
SILT
left-hand
and
side, we'll also show the
WS
code
standards
that is
have been
responsible
largely
for
displaced
National
in
Credit Union
small-scale and
Factory.
mobile computing
So as I
environments
mentioned,
by
for
HTTP
products,
and
there's two
JSON.
right off the bat,
But
National
SILT is
Savings
still
Account and
very
National
heavy
Loan
use in
Account.
enterprise applications.
When we expand this,
especially
we'll
those
see that
requiring
there's a
computer-to-computer
constructor that
communication.
returns a string. which
So,
indicates
web
that we're
services have
in
a
the
rich
National
history.
Savings Account.
And the only thing that's been
Note
constant
that
has been change.
it implements
In
iSavings
this
account
course,
just like it was
I'll describe
indicated
the
in our class
components of
diagram.
modern web services
The second
as
product
they're
is
used
essentially
today.
the same thing,
But you can be assured
except it's
that
for
new
a
techniques
loan
and
account.
formats will continue to
implements
emerge in the future.
iLoan account. And lastly, we have the concrete factory that we've been leading up to. And this has the operations that are
Let's talk
implemented
about
for
transport
create
protocols.
loan account
As I described
and
previously,
create
the
savings
early remote
account.
computing
Each of them
architectures
return a
predated
type.
the internet
And for the
used
first one,
whatever
it's
form of
iLoan account,
electronic communication
and for the
then
second,
available.
iSavings
The earliest
account.
forms of
And within
EDI,
them,
or
we
electronic
create an
data
instance
interchange,
of National
send and
Loan
receive
Account
messages
or
over phone
National
lines.
Savings Account.
First with telex
Next, we'll cover the
machines,
code
and then
that
move into
is used
bidirectional
to
modems.
provide
By the time of
the
the
factories.
introduction of
And that's
XML
going to
in
be in
1998,
our section called
the internet was
Providers, in
becoming
our project
commonplace.
called
And
Providers.
since computers
And
were already
then
being connected to
lastly
each
will
other
be
for other
the
purposes,
clients.
it was natural for web services to develop using one of the protocols developed
Now that we
specifically
have
for the
all
web.
our abstractions
One of the
and
earliest was
concretions in
FTP,
place,
or File
specifically the
Transfer
abstract
Protocol,
factories
designed
and
for
its
sending and
concretions,
receiving
and the
files
abstract
of all
products
types.
and its concretions,
An FTP
we're ready to
server is a
create the
computer
logic that
running
determines which
software that
factory
manages
needs to be
incoming
returned
and
dependent
outgoing
on a
files,
particular
usually
request.
located
And that's
on
where
that
the provider
server's
comes into
storage.
play. So
FTP
if
is
we
in
look
common
in
use
our
today
providers
for moving
project,
large files
you'll see a
around the
file
web,
called
but
Credit
it can
Union
also play a role
Factory.
in web
You
services.
can open that up.
A web service
And
that
when we
communicates
expand
over FTP
the code
is
there,
said to be asynchronous.
we'll see that we have
This means that the
logic
computers
that's
aren't
similar to what we've
communicating
done with the
each other
factory
in real
method.
time.
This, again,
Instead,
here
a
is
client
the
computer
essence
might upload a file
of
at
this
one
factory
point, and the
pattern,
responding
abstract
computer,
factory
the
pattern.
web service provider,
And it's
would
because
only
we have
discover
our
the message
if-else
when it
condition
pulled
that
its
determines
Dropbox
which factory is
folder.
going to be
It would then
returned,
create a
and that's
response
dependent
document
on whether or
and
not
place it
we
in an
pass in
outgoing folder,
the term
and
city
the client
or
would
national
also
in the
periodically
string.
pull for messages.
Moving on
and
to
eventually
our
discover
client,
and retrieve it.
to
and the
execute the
conversation
code,
would continue
let's step
in
through
that
what's
way.
going on over here.
Web
I
services
simply
based on
create
FTP
a list
are
of
by
account
necessity
numbers.
asynchronous.
One of them will be
because
for
clients
city,
and
one of them
servers
will be for
aren't
national,
immediately
and another
notified
one will be
of
for
new
an
messages.
invalid one.
They depend
Term
on
chase in
regular
there.
polling.
So I
But they're
iterate
easy to
through the
secure
list,
using the FTP
and I
server's
invoke
built-in
get
user
credit union
authentication
factory,
system.
passing in
And because
specific
FTP handles
account
large file
number.
transfers elegantly,
And here we
it can
check to
support
see
very
if the
large
account
web
is
service
null,
messages.
then we'll return a string that
FTP
says
is a
that
great
the
way to manage
account
a
is
computer-to-computer
invalid, the account number
conversation
is invalid.
where the messages are
Otherwise,
both
it
instead
will
of
do
just
two
a sentence
things.
or two.
The first,
SMTP
will invoke
and POP,
create
which
loan
stand for
account,
Simple Mail Transfer
and then we'll do
Protocol,
two things.
and Post
The
Office
first
Protocol,
is to invoke
are another set of
create
protocols
loan account
sometimes
on
used in
our
asynchronous
factory,
electronic
and
conversations.
then it'll indicate in the console
SMTP knows how to
which
send a
loan was it
message,
for. Was it for
and
city
POP
or was it for
knows how to
national?
retrieve it.
And then,
Both are
right
based on the
below it,
metaphor
we're going
of
to do
a
the same
central
thing
post
for
office.
with create
A web
savings
server
account
and a client
on the
can
factory.
each send
And
messages
it'll have a
through
value
shared
of
server,
either city
and then
or
periodically pull
national.
for responses.
Let's go ahead
Just as
and
with FTP,
build,
these
run our
protocols
program
are
to see
asynchronous
exactly
in
the
nature
execution.
and are useful
I'll
for
hold the
web
control
service
key down,
conversations
F5,
that don't need
so we can
immediate
hold on the
responses.
console.
Messages
And there
are
we have
uploaded to the email hub
So
with
for the first
SMTP
string that we passed
and
in,
retrieved with POP.
It said
The
return
content
city
of the
loan
messages
account. The
can
second
either
was
be
city
embedded
savings
in the
account.
email or
And the
attached
third
as a
and
separate
fourth were
document.
both for national.
But by
First
far,
for loan,
the most
second
popular
for a
transport
savings,
protocol
and the
today
last one was an
is
invalid
HTTP,
account number, so we
or
got
Hypertext
that error
Transfer
indicating that it
Protocol.
is invalid.
This is
And
the
that
same
is
protocol
about
used by
it.
web browsers
So just keep
and
in mind
other
that
client
an abstract
applications to
factory
communicate in
pattern
real time
is
over
very
the
similar
World Wide
to
Web.
the factory
HTTP
method,
is a
except
simple
that everything
text-based
is at
vocabulary
a higher
that lets
abstraction
computers
level.
exchange
It's
requests and
most easy to
responses.
think of it as a
A
factory
web
of
service
factories
conversation over
because
HTTP
we have
starts
logic
with the
that's hidden
client
behind the
computer
scene that
forming and
determines
sending
whether or
a
not
request
to
message.
send
The
factory
server
A
receives
versus
and
factory
processes the
B
request,
versus factory
executes
C.
whatever actions are requested, and then forms and sends back a response.
The Gang of Four
An
describes
HTTP
the
server
singleton
is
pattern
said to be
as
always
ensuring a
listening for
class has
requests,
only one
and
instance
given adequate
and provides a
resources,
global point
should
of
always be
access
able
to
to
it.
provide an
So
immediate
what does that really mean?
response.
Singletons
HTTP
are
is perfectly
used
suited
when
for
you want to
synchronous
eliminate the
communications,
option
where
of
a client sends a
instantiating more
request
than one
and
of the
waits for a
same
response
object.
before
So
doing
for example,
anything else.
if you log in online to
HTTP
your
requests
insurance
and
company's
responses follow a
website to
strict
make a few
vocabulary.
changes to your policy,
Each request
there
is
should
of
be
a
only
particular method
one
or
instance
verb
of that
such as
policy
get,
object during the
post,
whole time that
put,
you're
or
logged on
delete.
making changes.
The most
We'll
common
be
kind
going
of
through an
request is
example
called a
to
get
create a
message.
singleton that
It's
manages an
typically
instance
formed
of an
as a
insurance
uniform
policy
resource
object. But first,
identifier.
let's take a look at the
Here's an
class
example.
diagram for a
I'll
singleton.
go to a web
The Gang of
browser
Four
and
says
enter
that
the
a
URI
singleton defines an instance operation that lets clients access a unique instance.
which stands for
Now you
plain
can see
old
here
XML.
at the top we have the
/tours.php.
different operations and different methods, static
This
instance,
retrieves data
singleton
from the
operation,
server.
get singleton,
And this is a web
below
server.
are some properties.
The data is
and
returned
this
as
is
XML
singleton
because
data.
I requested
Now
it
understand
that
that when
way
we're
as
looking
part
at
of the
class
URI.
diagrams for these patterns,
But if I
sometimes it
instead
might
type
be
in
some
JSON
small
there,
variation
I'll
when
get
we
back the
actually
same data
execute it.
in
But in
JSON
general,
format.
this is the essence of it.
I'll go
Okay.
back to the XML
So for our
because
example,
it's easier to read.
what we'll do is that it'll
This
be
URI is
to access
translated
an
by the
insurance
browser,
policy
and
instance.
this is what it looks
Now
like
the
when
Gang
it's
of
sent
Four
off to the
also
server.
says that, according to
The
this class
first word
diagram,
in the HTTP
that a singleton may be
request
responsible
is the
for
verb
creating
or
its
method,
own
in
unique
this case,
instance. Again, for
The next
our
part on
case,
the first
our
line is
code will
called the
know
resource
when to
root,
and when
typically
not to
contains a
create a
directory
new
or a set of
policy
directories,
instance.
and might end with a document name as it does here. And the last part of the first line is HTTP.
Okay, so
And
let's
the
go ahead
version
and
of
open up
HTTP
our
being used by
exercise
the
file
client.
that covers
The
singleton
next
for
line
this
is the
particular
host
chapter.
that the
And
service
what we're
is
going to
being
go ahead and
requested from.
do is, before we get started, I want to show you that on the left-hand
The
side of
user
the screen,
agent
you
is
see
a
that
string
there's
that identifies
a
the
pane there
client
called
making
Test
the request.
Explorer. If you
And the
don't see
rest of
that,
these lines are
you can go to the
HTTP
top
headers
nav
that
bar
modify
and
the
choose
request in
Test,
some way.
Windows,
I'll describe some of
and then
these
you have an
HTTP
option
headers
for Test Explorer
throughout
to
this
pop that
course.
pane up.
The most common kind
The
of
first thing I'd
request
like
in
to do
HTTP is a get method,
is
but there are
make sure
many
that
other
we
kinds of
look
methods
into
as well.
our policy class
This is
here.
a
You'll notice that
complete
there's two
list.
projects, a singleton
Get,
project
head,
and a singleton
post, put,
.test
and so on.
project. So
Not all
let's go
clients
into
support
our
all
policy
verbs,
class.
but all of them
and quickly
support
skim
get
over
and
what's
post
in there.
minimally, and most of them
There's
support
the class
get,
itself, and there's
post,
two properties
put,
in the
and
method.
delete.
One property for
Those
ID
are the
and
four
one
most popular verbs
insured.
used in web
That's
services.
assigned a value
And in
of
the context
John Roy.
of one kind of web
ID is
service,
1, 2, 3.
known as a
The
RESTful
method simply
service,
returns
each
the
verb has its own
insured
meaning.
name. Now,
Get means I
let's
need some
hop
data.
on over to our
Post means
program file.
add this data to the
And all we do
server-side
here
repository.
is create an instance
Put
of
means
the
update the
policy
data in the
class,
server environment,
and then
and
call
delete means
the
delete the
get
data.
insured name
These HTTP
method,
methods don't
which
map to
returns
those actions
the name,
automatically.
and then we print it out to the
They have to
console.
be
So
interpreted
let's
by
build
the web
this.
service.
Just make sure it's
And
running
not
as
all
we
web
expect.
services are sensitive to all HTTP methods or verbs.
I like to hold the control
Some
key
web services
down
will
and
do
hit the
exactly the
F5
same
key, which
thing, no matter
execute the
what
console
method you
application
use.
holds the console
And
lock
others only
so that
accept
you
a
can read what's up
particular
there. It's the
method,
equivalent of
like a
having
get
a
request.
console
It's up to the
read
service.
line in your program.
And you need to
And
study
John
your
Roy,
web
there you have
services
it. Works as we
documentation
expect.
to know what that
Now
web
this small
service
program
expects.
here is a great candidate for a
Here's some
singleton
more
because
about
for an
HTTP
application that
requests.
handles an
A
insurance
get request
policy,
is formed with a
if there's
URI.
going to be one insurance
Uniform
policy
Resource
for a
Identifier.
person logging in, we
This
don't
is
want to
one
create a
version
new
of the
instance
URI that
each
works
time.
in the web
Throughout the
service I
life
showed.
of
It
the
starts with
program
the
while
protocol,
the individual is on there,
If
we
this
only
were a
want to have
secured
one
web
instance,
service,
not
it
multiple
would start
floating
with
around in memory.
HTTPS.
So
The next
let's go
part
ahead
is the
and
host,
comment out
also
this
sometimes
first
called
line
the
that
domain
creates
root.
a new instance of
After that is the resource
policy
root.
class.
The
And then what
resource
we're going
root
to
sometimes
do
points
is
to a particular document,
change
in
the
this
word
case a
policy
PHP
here
script, but
on
can
this
also have its own unique
line
syntax.
14
And the last
so
part
that it's
after
a
the
capital
question mark
P and points
is the
directly
query
to our
parameters.
class.
The
And then we're
filters
going to
that
add
you
the
might want
word
to apply.
instance.
Going back to my browser,
It's
I'll
complaining now
try
because
a
we
query
haven't
parameter on this
updated
web
our policy
service.
class yet
I'll
with
add
this
to the end of
definition.
the URI,
So let's go ahead and
question mark,
save
package ID
and move on
equals
over to
1.
our
And that
policy
results in
class.
getting back a
Make the
different set of
appropriate
tours.
changes.
I'll change the value of the package
First thing
ID
I'd like to
query
do
parameter to
Here
5.
is
And that gets
create
back
a
still a
default
different
constructor.
set.
To do that,
Not all
sometimes
web
we'll type
services
in
support query
CTR as a shortcut,
and the particular
hit the
names,
tab key.
data
That
types,
by
and
default
allowable
creates a
values of
constructor
the
for you.
query parameters are dictated
Right
by
above
the
it,
service.
We're going
Again,
to go
check
ahead
the
and create
documentation.
our instance
Some web
definition.
services can accept post
Public.
and other types of requests.
It must be
And this is
static
what they look like in the
it's gonna
HTTP
be
vocabulary.
of the type
Post post
see?
request starts with the
Sure,
verb
we
or
typed that
method
in correctly.
post
Instance.
and is followed by the resource route.
And what
Then
we're
the
going to do
version
is
of
set
HTTP.
the getter.
The next line will have the host
Return
that the
an
request
instance
is
of
going
this
to.
object.
and then some other information about what's being
Specifically,
requested.
a
The
new one.
content type tells you where the request is coming from.
There you go.
This content type
Now,
is coming from
this
a
is
form
not
in
a
a web
singleton
page.
yet,
And the content
because
length
a new
is the
instance is
length of the
created
request.
each time. And to
And a
prove
request
that,
coming from
what I want
a
to do
form on a web
is move
page.
on over to our
Parameters
test
are added
project
to the bottom of
and
the
run a unit
request
test
as name-value
to show
pairs.
that will fail.
But that's
So
not the
navigate
only
on
format
over,
that's supported by
and what I'd like you to do
HTTP
is rename
HTTP
test
requests
method
can also include
1
XML
to
packets. In
is
this case,
policy
there's a
a
content
singleton.
type header saying I'm sending you XML, and an accept header that's saying I would like to receive
And then what we're going
XML
to
back.
want to do is
And the parameters
doing
are
a
a part
assert,
of an XML formatted
check to see if
package.
two objects
Just as with
are
all
the
web
same.
service syntax, this would be unique to this particular web
and the two
service.
objects we
There
care
is no
about.
global format for
policy.
how these parameters
And
are
by the way,
supposed to look.
IntelliSense here is
And
saying,
this is an example of the
is
same sort of
policy a
request,
singleton?
but with
It thinks
JSON
that's what I
instead
want
of
to go ahead
XML.
and type in, but
Once again,
that's
there's an
not.
accept
So I'm
and a
going to hit the
content
escape
type
key,
header and the
hit the
request
period,
data,
and type in
this time
instance.
formatted in JSON.
And then I'm going to type
The response from the server can
escape
be
key,
in a
then
number
type
of
in
different
policy.
formats. This is an
This
example
again.
of an HTTP header where the data is being returned
Now
as
we're going to
XML.
build.
The first line has the
If
version
it's
of
complaining,
HTTP.
as it
Then
does
a
in the
response
bottom
code.
for me right now,
The response code 200
this
means
name
everything
policy
worked
singleton
okay,
test does not exist
and a
in the
response
current
code of
context.
404 would mean that
If we
resource
save
wasn't
everything as
found,
complaining,
and so on.
if you do
You can see
control
a complete
period
reference to these
under word
codes
policy,
at
it
the
should give
website
you the option to
http://stat.
import the
That's
namespace.
http
Sometimes it might be a little
stat.us.
buggy like this, but
The response
really
header
should
then
have
tells the
recognized
client
it
what
without
type of
the
content is being
namespace.
returned.
Matter
This
of
is also
fact,
sometimes known as the MIME type, and how long
I'm
the
going to comment
response
this out
is.
right now.
Then,
do build
after a
again,
blank
still
line, the
recognize
actual
it.
response
so it really
message
didn't
is
need this
included.
namespace. It was like
And
a
it
little
can be
buggy
in one
here.
of many
But let's
formats.
continue on.
XML,
So we have our
JSON,
test here,
simple
our
text,
test case.
whatever is
Let's go
required by
ahead
the current web
and
server.
run it.
HTTP is easy to use for
And
security
it fails.
communications.
And the reason why
Security
is
comes in two
because
major
each
parts.
time called upon
Authentication of
instance,
client
we created
requests
a new
and
one.
encryption of
We had no
messages.
control over
And there are many
when
ways
it had
to
to
authenticate
create a new one
users,
versus
starting
using an
with basic
existing
security,
one.
a
So
model
that's what we're
built
going to
into
go
all
ahead
modern
and
HTTP
do
servers,
now. Let's
and
jump to
continue
our
through
policy
API
class.
keys and token-based authentication
And what we're gonna
standards,
do
such as
is create
OpenID and
A
OAuth.
private variable
Nearly all modern HTTP clients and
static
servers can communicate with
type
SSL,
policy.
or Secure Sockets language,
We'll call this
a standard for
underscore
encrypting and
instance.
decrypting internet traffic,
in our
so
getter,
it can't be easily intercepted.
we'll put a condition
So
to
regardless
check
of which
to
message
see
format
if
the
this
web
instance
service
already
uses,
exists.
XML, JSON, comma
instance
delimited
is
files,
null,
or a proprietary binary format.
then it's
Your
okay
web service
to
will
return a
almost
new
certainly
policy.
send and receive messages
Otherwise,
over HTTP. That's the
return
transport protocol used by the
current
vast majority of the web
instance.
services universe. And it's the one
And
we'll focus on in this
specifically,
course.
we don't want return here. We want to have this instance be equal to a new policy. Okay.
One of the most
Now
important
if we build, looks like it builds okay. Now if we go to our test, right click and run selected test, it passes. And so now we have a true singleton. However, we're not completely done yet. This is one way of doing a singleton, but it is not thread safe. And that's what we're going to go ahead and tackle next. So we have our singleton, but it's currently not thread safe. If an app is using our code in a multi-threaded environment, two threads can hit this if statement here on line 14 at the same time, and we still end up having multiple instances created. So to avoid this, what we can do is lock our code, and we do this by adding a private read-only object variable such as private static read-only, and it'll be a type object, and we'll call it underscore lock. And then what we want to do is wrap our if condition in the lock. We use the keyword lock to actually lock it. Underscore lock, open parentheses, and that second parentheses needs to be closed after the return statement. Okay, now if we save, build, and right click to run our test again, everything still works. And this is a popular approach, but we can do even better. What we can do is, let's go ahead and comment out this line here on 11 with lock. And what we'll do is create a read-only statement over here on line 13, private static read-only. And we're going to create a new instance of policy on this line immediately. And what this allows us to do is basically get rid of everything that's in here and just return the instance. Now it's complaining down here. Let's see why. There was an extra parentheses right there. Okay, so now let's go ahead and build. Everything builds, and if we run the test again, everything passed. So this is shorter, it's cleaner, and what happens is the CLR will handle the rest. The Gang of Four says that the decorator pattern attaches responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. My simple definition of this is that the decorator pattern is all about using composition and limiting inheritance to simplify object relationships, making them easier to update or manage. So, what's the process for this pattern? Well, it boils down to wrapping objects. In fact, sometimes a decorator is called the wrapper pattern. Let's say I'm on an online system to order a car, and this system would let me choose features like the size. And let's say, for example, it's a compact car. I want to add features to this car, and rather than using inheritance, I can add decorators as features. For example, I can add navigation as a feature. I am wrapping the compact car in a navigation decorator. If I wanted to add a sunroof, I can add a sunroof decorator, thereby wrapping the navigation. If I want to get fancy and add leather seats, I add a decorator for that, and then I wrap the sunroof. So I started off with just a compact car, but then was easily able to just add decorators. Now if I need to get the car price, I just need to call the method on the outermost decorator. Leather seats is going to hand off computing the price to the object it decorates, which is sunroof. When it gets the price, it will include the additional cost for leather seats. Likewise, sunroof adds its additional cost after getting a price from navigation. All this is done at runtime and uses business logic to determine what kind of decorators are added and removed. Let's look at the class diagram. Now here we have the class diagram. At the top we have component. That's going to be our car, and it has operations. And we could have operations such as get car price and get car description. The component defines the interface for objects that can have responsibilities added to them dynamically. We also have concrete component right below it. That defines an object to which additional responsibilities can be attached. So an example of concrete component for us could be compact car or full-size car. Also we have decorator. So in our code, we could simply name a class called car decorator. That maintains a reference to a component object and defines an interface that conforms to the component's interface. And lastly, we have concrete decorator. For us, that could be a leather seat or navigation. That adds responsibilities to the component. Let's go ahead and take a look at some code to solidify this. I'm going to continue with the car example, so let's open up the solution for decorator from your exercise folder, and I'll step through this code. Now on the right hand side of the Solution Explorer, you should see that I created a folder for each of the key classes I showed in our class diagram. component, concrete component, decorator, and concrete decorator. And if we were to flip back to our class diagram, we have component, concrete component, decorator, and then our two concrete decorators. Let's first go to the component folder and open up car. The component from the class diagram is the car, which here is an abstract class that has two abstract method signatures and a property. Property being description, and the two abstract methods being get description and get car price. Very straightforward. Now let's navigate to the concrete components folder and open up compact car. This is our concrete implementation of the component. I created two files like these, one for compact car and one for full-size car, which is very similar to the code here. But let's focus on compact car and step through exactly what we're doing here. In the constructor, I defined a default value of description being compact car, and then we simply override the two method signatures that we had in our component. Get description, which returns a description, and get car price, which will return a value of $10,000. The way that the methods are written here is using a new feature in C# 6 called expression body function members. Feel free to go ahead and take a look at my course, C# 6.0, First Look, for more information on these features and more. Next, let's go ahead and take a look at the decorator, and that is in the decorator folder. We'll open up car decorator. The decorator class here gives me the ability to add features to my car and adjust the price accordingly. I set a private variable for underscore car, and in the constructor accept an instance for a car that's assigned to the private variable. And with that instance, I implement the abstract method by overriding the get car price and return the price of the car. And likewise with that instance, I override get description and return the description. So we looked at our component, concrete component, and our decorator classes so far. Right now, let's go ahead and take a look at our concrete decorator. So that will be under our concrete decorator folder, and we will open up leather seats. Here is a crucial logic that permits the wrapping of decorators. Notice that the leather seats constructor takes in a car parameter. It then passes it along to our decorator. I set the default description to leather seats, and then it is used right below where get description concatenates the description passed in with the current description, which here is leather seats. As a result, when I run the program, it will print a description with all the features we added as a result. So likewise, the price is updated in the same way by adding the price of the leather seats, which is $2,500, to the current cost of the car. Now let's swing on over to our program file. So what I'm doing here is creating an instance of a compact car. I could run this and it'll just give me that standard rate and description. Right now I just counted out the decorators. I want to show you what it looks like without any decorators and just the instance of the compact car. Shows compact car at the price of $10,000. But we can wrap this compact car with our navigation decorator simply by uncommenting this line. So now our variable, which is the car, is of type navigator. So when we call get description, we're calling it on the navigator. Let's go to our navigation file. So the navigation object will get the description of the compact car, which is passed in via its construction here on line 13. And the same logic applies to calculating the price. When we run it and add multiple wrappers, for example, if we added sunroof and leather seats, we'll get compact car, navigation, sunroof, leather seats, and a new price that includes every feature in addition to the $10,000 for the car, which totals to $20,000. What's nice is when adding new features, I didn't have to go to change any old code, so it adheres to the open-close principle. and I can add an infinite number of features to decorate it with ease. And that's one of the main benefits of the decorator pattern. The iterator pattern is described as providing a way to access the elements of an aggregate object sequentially without exposing its underlying representation. My simple definition is that it's a way to access and iterate through elements of a collection in the same way despite the type of collection, be it an array, dictionary, list, or whatever. Note that sometimes iterating is often referred to as traversing, and the collection can be referred to as a container or an aggregate. Now let's think of an example. Let's say we need to collect names of reporters that work at the New York paper and the Los Angeles paper. Both companies provide me an access to their list, but the New York paper reporters are in an array, and the Los Angeles paper reporters are in a list object. I don't want my code that accesses the reporters be inconsistent, be it a collection of arrays or lists. And iterating through any of those collections should be done in the same way. And that's what the iterator design pattern lets us do. Let's take a look at the class diagram. Our main abstractions are the aggregate on the upper left-hand corner and the iterator on the right-hand corner. And the concretions of them, respectively, are below. The iterator on the right-hand side defines an interface for accessing and traversing elements, iterating through elements. Right below it is a concrete iterator. It implements the iterator's interface. It's where you say how we access the array or list. It keeps track of the current position also. On the left-hand side, for the aggregate, that defines an interface for creating an iterator object. And below it, for concrete aggregate, it implements the iterator creation interface to return an instance of the proper concrete iterator. Now this is all going to start making a lot more sense when we look at some code. So let's go ahead and do that now. In our class diagram for the iterator pattern, we had 4 key classes. At the top, we had the aggregate and the iterator, and those were their abstractions. And then below them were their concrete implementation, the concrete aggregate and the concrete iterator. In Visual Studio here, let's open up our exercise folder and navigate to the solution for the iterator pattern. In the Solution Explorer, you'll notice on the right-hand side we have a folder for aggregate and a folder for iterator. Let's start off with the aggregate and open up iNewspaper. Our aggregate is very straightforward. It's an interface that's called iNewspaper, and its definition is create iterator of type iIterator. Moving on next, we can look at the concrete implementation. Let's first look at LA Paper. LA Paper implements iNewspaper, and it has a collection. The collection is an array of reporters. And what we see here is I have a private variable called _reporters, and within the constructor is the array. And right below it, we have our method createIterator, which returns LA iterator, which will be wrapped within the type of iIterator. LA Paper iterator takes in a collection of reporters, the array. If we take a look at our next concrete implementation, New York Paper, it is structured pretty much the same way. The exception is that it's a list rather than an array for the New York Paper. But it also has a create iterator, which returns New York Paper iterator, taking in the collection and its parameter, and it returns New York Paper iterator, which takes in the collection of reporters, and the method itself returns iIterator. And that's it for our aggregators. Next up, we'll talk about the iterators and the client that executes the program. So we just reviewed the code that's in our aggregate folder. Let's take a look at the code within the iterator folder now. First, I'd like to open up the file iIterator. So within here, we simply have an interface called iIterator. And the signatures consist of first, which returns a void, next, which returns a string, a boolean called isDone, and a current item, which will be returning a string. First simply sets the current element to the first element. Next advances the current element to the next one. Is done basically checks to see if the collection is at the end, and current item returns the existing element, the current element that has a focus. Let's open up LA Paper Iterator. LA Paper Iterator inherits from iIterator, and you'll notice we have a couple of private variables, one for reporters and one that keeps track of the current element. Then we have a few methods: LA Paper Iterator, current item, first, is done, next. These are the implementations for what we just saw in the iterator. And here is where the differences come in, because the way that we're going to handle an array or a dictionary or a list, all of that is going to be different, and the code, unique code for each of those collections will be reflected here. So for example, if we take a look at how we handle is done for LA Paper Iterator and then open up New York Paper Iterator, New York Paper Iterator checks the count on the reporters, whereas for the LA Paper Iterator, it checks the length. Likewise, if we look at how it handles next, for the LA Paper Iterator, because we're dealing with an array, we're passing in an index, and so it's the current, and we increment it there. For the New York Paper Iterator, we call element at. And so there's a small difference, but these differences could be much huger. And the nice thing is that they're separated. So these iterators, these concrete implementations, in short, is where we actually indicate how we're going to handle the extraction of the items from the collections. Now let's move on to our program file, which consists of our client code. Here I create two instances of our papers, the New York paper and the LA paper. And then I simply invoke a create iterator for each of them. And what's going to happen is I get the values from the collection, but the logic that handles how to extract the items from the collection is separated from the client. So right below my invocations of create iterator for the New York and the LA paper, I write out to the console and I call print reporters and pass in the collection. Well, print reporters uses our interface. It uses our pattern that we just set up to call the common interfaces that we need. So for example, over here we call first to initialize the collection. And then we have a while statement that checks to see if the collection is not done, then continue to the next and print it out to the console. And no matter what collection type that we're dealing with, we're always going to use these methods. First is done, we have current item, we have next. Those are going to be the common ones. And that's the nice thing about the iterator pattern, because it simplifies the way that we're going to handle the collection and iterate through them through the client. So if we go ahead and run this, we see the output of the collection, and it goes through and prints out all the reporters from the New York paper and the LA paper without any issue. So if you're ever in a situation where you're dealing with different types of collections, maybe one might be an array list, another might be a dictionary, or whatever it could be, consider using the iterator pattern so that this way you have a standard form of traversing through that collection. The observer pattern is described as defining a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. So this is one of the clearer definitions, but we could do even better. This pattern basically states that the change in one object causes a change or action in another by notifying it. Let's take a look at the class diagram. Now here we have two abstractions at the top. We have on the upper left-hand corner the subject, and on the upper right-hand corner the observer. The subject knows its observers. Any number of observer objects may observe a subject. It also provides an interface for attaching and detaching observer objects. Now the observer defines an updating interface for objects that should be notified of changes in a subject. Now below them we have our concrete subject and concrete observer. The concrete subject stores state of interest to concrete observer objects. It sends a notification to its observers when its state changes. The concrete observer maintains a reference to a concrete subject object. It stores state that should stay consistent with the subjects. And lastly, it implements the observer updating interface to keep its state consistent with the subjects. Now that's a mouthful. Let's talk about it in a real-world example. Another common term used to describe this subject-observer relationship is publisher and subscriber. The latter makes it pretty easy to compare to a real-life scenario. For example, when you're a subscriber to a blog or an email list, you get notified when a new article comes out by the publisher. On Instagram, when you follow someone, you're a subscriber and they're the publisher that notifies you. In Windows, there's event handling which uses the observer pattern. The clicking of a mouse on an image can cause an event to occur because in the code there was an object subscribed to a publisher object which notified it to take some action like closing or opening a window. Let's review some code to demonstrate this, which also takes into account what we covered in the class diagram. Let's open up the exercise folder and navigate to the solution for observer pattern. In the world of Twitter, celebrities have many fans on Twitter following them. What we're going to do is review a small console application that notifies a fan when a celebrity they follow tweets. I'll show you how it demonstrates the observer pattern by having the subject, our celebrity, and observer, our fan, and the concrete subject and concrete observers, which are the implementations. Something to note. What we want to focus on is not the notification itself, which will just be an output statement to the console, but rather the process that leads to notifying, which demonstrates the observer pattern. So let's first go to the subject folder and open up the file iCelebrity. Our subject is fairly straightforward. I created the abstraction of our subject with it being an interface called iCelebrity with a few properties, full name and tweet, both of them are strings, and then some method signatures for notify, add follower, and remove follower. The notify signature will take in a tweet as a string parameter, and both the add follower and remove follower will take in ifan in the parameter. Next, let's move on to our observer folder and open up ifan. Our observer is fairly straightforward. It's an interface that's called ifan, and it has one signature that is called update, which takes in an iCelebrity. So if we were to flip back to our class diagram, so far we've covered our subject on the upper left-hand corner and our observer on the upper right-hand corner. Now we're ready to review some of the code for the concretions. So let's go to concrete observer folder and open up a fan. Here I created the concrete implementation of our ifan abstraction. I did this by creating a fan class that implements ifan, which sends out the notification indicating the celebrity name and their tweet. Alright, so that is it for our observer, our concrete observer, and our subject. Okay, now we'll review the concrete implementation of our iCelebrity abstraction, which was our subject. Let's navigate to our concrete subject folder and open up gclooney. So this class gclooney implements iCelebrity. The first thing that you'll notice is that I have a collection that I set up of fans, and that's because we're going to be keeping track of the fans that we add and remove. If we scroll down, you'll see that there's a method for add follower and remove follower, and those take in an ifan. Now moving back up, A couple of things to point out. One, we know we're going to keep track of our tweets. So I have a backing field, _tweet, and a property for tweet with a getter and a setter. The getter simply returns the tweet, but the setter actually takes in the current value of the tweet and notifies our fans. If we navigate on notify, it brings us to our notify method, and for the notify method, it takes in the tweet as a parameter, and then it iterates through the collection of fans and invokes for each one the update method and passes in this. So that this way, for each time there's a new tweet on a particular celebrity, a fan gets notified with the name of the celebrity and the tweet. So now let's navigate to the bottom of our project observer pattern and open up our program file, and we'll review the code that executes this application. So in our main method, the first two lines simply invokes an instance of each celebrity, one for G. Clooney and the other for T. Swift. And for both of them, we pass in a string which represents the tweet. Then we go ahead and create an instance of two fans, a first fan and a second fan. After that, we add those fans to the celebrity. One for G. Clooney, and that'll be the first fan. The second fan will be added to Taylor Swift. So at this point, when we invoke a tweet on G. Clooney and pass in the value of "my wife didn't force me to tweet," his fans will be notified. And the same applies to Taylor Swift. So let's go ahead and run this program and see how the output actually looks. Fan notified tweet of George Clooney, "my wife didn't force me to tweet," and fan notified tweet of Taylor Swift, "I love my new music." So whenever you come to a situation where you see that you have a possible publisher that might make some type of notification and its subscribers that needs to be notified, think of the observer pattern. One of its core benefits is that it sticks to some of the solid principles, particularly being able to extend the application without having to change any existing code, and it makes it a lot simpler to maintain. Since the Gang of Four initially defined 23 design patterns, many others have been created to build on their foundation. One common addition is the repository pattern. On Microsoft's MSDN website, it describes the repository pattern as separating business logic from interactions with the underlying data sources. In short, using a repository allows programmers to create an abstraction between an application and its data layer. In a lot of programs, the business logic will need to access data from databases, web services, or some other data stores. The problem is, directly accessing the data can cause issues like duplicated code, programming errors, or coupling code, making it difficult to test. In order to avoid these, developers use the repository pattern. This helps facilitate unit testing and improve the code's maintainability. In the discussion we're going to have about applying the repository pattern, we're going to be looking at an existing MVC application. The project has lots of files automatically generated after using Visual Studio to set it up. So that you're familiar with them, let's go ahead and create one now. It'll be a project that maintains a list of students and faculty in a database with basic operations to create, read, update, and delete records. So let's go to File and start a new project. Make sure that Web is selected under Visual C#, and then we choose ASP.NET Web Application. Let's give the project the name of Student DB and click OK. In the next window, make sure that we select MVC and that nothing else is selected under it besides the default MVC, which should be automatically selected. And on the right hand side, confirm that host in the cloud is not checked. Then for change authentication, make sure that we select no authentication. Then click OK and OK to move on. Visual Studio will start generating the project. Okay, so you'll have your default screen that says your ASP.NET application, and the first thing that we're going to want to do is build our model. So let's go to the model folder, right click, and we're going to create a student model. Select add, select class, and we're going to enter in student. Then we'll add in a couple of properties. Shortcut that I like to use is just to type in prop and hit the tab key, and I'll enter in student ID, then give it a name and a year, and the year is actually going to be a string because we're going to be just saving words like sophomore and freshman. Alright, that is it for student. Now let's go ahead and create one more for faculty. Right click on model, select the class, and we'll call this faculty. And the faculty will simply have an ID and name. Okay, let's go ahead and compile. And the next thing we need to do is create two controllers. We'll do the first for student. So let's right click on the controllers folder and click add, select controller, and we're going to select MVC5 controller with views using Entity Framework. Alright, choose add, and now we have our add controller dialog window that comes up. For our model class, we'll select student, and for our data context, we'll add one, and by default it'll give us a name, StudentDB models .StudentDB context. That's good enough. We'll click add here, and for the student controller, I know that I chose use async controller actions, so let's check that and click add. Visual Studio starts gathering all the necessary information, such as third-party software for the application, generating the code that's needed to build the views to create, update, and delete. That's what it was doing while it was scaffolding. Okay, and now we have all this code that's generated. And later on, in our next videos coming up, we're going to be modifying this, but I wanted to show that all this is generated when we're just setting up the project. So let's go ahead and do the same for faculty. We'll add a controller. We'll select MVC5 controller with views using Entity Framework again. Select add. For the model class, we'll choose faculty. At the bottom for the controller name, change it to pluralize it, faculty. I'll just keep that as faculty. And for the database context, we'll leave it as student DB context. And I will uncheck using async for faculty, and we'll select add. Alright, this gave an error here, and that's just because we needed to build right beforehand. So let's go ahead and build a solution. Okay, and take another go at it. Controller, MVC5 controller with views using Entity Framework. With a model class, faculty. Uncheck async. Unpluralize faculty. Add. And there you go. It's scaffolding. Okay, so the next thing is, because we're going to be making changes to the database, I need to enable migrations. So I have the Package Manager console here. If you don't see it at the bottom of your screen like I have, go to Tools, select NuGet Package Managers, and then you'll see a Package Manager console in a context menu. So let's go to the console, and what I want to do is enter in enable migrations dash enable automatic migrations. And we shouldn't need this force, so I'll remove that. So when I hit enter, Entity Framework finds changes in our database schema and creates the code needed to update the database to the new schema. Alright, once that's done, I'll enter in update database, hit enter, so it recognizes the changes we made, and that should be it with the console. So the very last thing that we need to do is add our links for the student and the faculty, and that is going to be in the views folder under shared. You'll open up the layout, and we basically need to just add 2 links. I'll copy the last one, paste it twice, and modify the link so that it says students, and we're going to be pointing at our index, and for the last parameter it's students, and we're going to do the same for faculty. Okay, so now if we run the application, ideally should come up with our links, and we should be able to click on students, and great, looks like everything's working. We have the option to enter in the student name and year, hit create, and boom, it saved it to the database. Okay, so now you see essentially what I started off with before making any changes to apply the repository pattern, which we can now move on to. I have here an MVC application that maintains a database of students and faculty members. What I'm going to do is step through the relevant parts I added and changed to convert the architecture to conform to the repository pattern. So the first thing I did is created an interface called iStudentRepository, and that's in the DAO folder. So let's navigate to the DAO folder and open up iStudentRepository. Now the code here is fairly straightforward. It declares a typical set of CRUD method signatures, CRUD standing for create, read, update, delete, and it includes 2 read methods, one that returns all student entities and one that finds a single student entity by ID. The next thing I did is created a student repository class, which is the concrete implementation of this interface. That's also in the DAO folder. So let's open that up. So there's quite a bit in this file here, so I separated the code into parts. In part 1, I have the repository database context defined as a class variable, and the constructor expects the calling object to pass in an instance of the context. In part 2, I simply implement CRUD operations. So for creating, I have insert student. For reading, I have 2 methods, getStudent by ID and getStudents. GetStudents returns a list, whereas getStudent by ID obviously returns 1 student, 1 record. Then that's followed up by updateStudent. That method simply updates the record. And next is deleteStudent. And the next thing that I have is a general save method. Part 3 is where we do our cleanup. Because this class implements iDisposable, we're able to use a dispose method and add a little bit of logic to indicate when and when not to dispose our context. The next step I took was to make some changes in the controller, specifically the student controller, that will allow it to reference the repository so that we're using it. So let's navigate to the controllers folder and open up student controllers. Here in the constructor, I update line 22 to reference the student repository. In fact, there's several areas in the code here where we simply updated it to reference the student repository. So for example, in the index method on line 28, we have an await student repository. Following that is a details method. On line 39, await student repository. And it goes down the line. For create, over here on line 48, I didn't make any changes, but for the HTTP post version of create, I do have some changes, and that's on line 63 and 62. I reference the student repository. So keep in mind to take a look at the comments, because I might have a method that's called edit here, and right below it there's another method called edit. This one on line 70 is for get, and on line 87 is for post. Both of them I made a small change and made a reference to student repository. And following the edit methods comes the delete method. Again, another reference on line 112. And last but not least, there's the delete confirm method and the dispose method. Both of them reference the student repository. And that's about it for having the groundwork done to set up a repository. What I've essentially done is I've created an abstraction layer between the controller and the database. This pattern is great for testing, because if I were going to unit test with this application, I could create a mock repository class in a unit test project that implements iStudent repository to test controller functions without tampering with real data. Now, sometimes we may deal with more than one repository. That's when having a generic repository comes in useful. That's up next. Create Creating multiple repository classes for several entity types could result in a lot of redundant code, and it could result in partial updates. For example, we do have another entity besides student, like faculty. What if I have to update both as part of the same transaction? If each uses a separate database context, one might pass and another might fail. Well, one way to minimize redundant code is to use a generic repository. And that's what I've created in this instance. If we navigate to the DAO folder, open up generic repository, I also broke down the code here into several parts. In part 1, I declared class variables for the context and for the entity set that the repository is instantiated for. Right below it is the constructor, which accepts a database context instance and initializes the entity set variables. In part 2, the get method uses Lambda expressions to allow the calling code to specify a filter condition and a column to order the results by. Now, I won't get too deep in this area because you might create a generic repository that's slightly different. The concept of having a generic repository is going to vary from project to project, and it's all going to depend on the types that you're going to be dealing with that you need your code to handle. So let's move on to part 3. And the code we have within getById, insert, and update methods is very similar to what we just saw in our non-generic repository. Rather than using student, we're passing in t-entity or object to keep things general. In part 4, I provided 2 overloads for the delete method. One will let you pass in just the ID for the entity to be deleted, and one takes in an entity instance. Now this project is in a good state to handle multiple repositories, and a good consequence of that is that it's structured to be able to handle a new pattern, the unit of work, which is designed to handle multiple repositories. That's up next. Another pattern that is often used with repositories is the unit of work. Unit of work was outlined by Martin Fowler in his book, Patterns of Enterprise Application Architecture. On his website, he describes the unit of work as a list of objects affected by a business transaction which coordinates the writing out of changes and the resolution of concurrency problems. Basically, it allows programmers to update and keep track of data changes in several objects, like multiple repositories, to save to the database in one transaction instead of multiple transactions for every change. For example, assuming I'm dealing with the model view controller application, this diagram shows how it all fits together. On the left, after requests come into the controller via IIS, which is Microsoft's web server, you'll notice both repositories are in the unit of work, which also contains the database context, where it keeps track of changes. It then sends commits to the database either directly or possibly using an object relational mapper like Entity Framework. On the right, we see how we use the unit of work pattern when unit testing with mock repositories. In fact, it's most useful when dealing with multiple repositories. Martin Fowler summarizes it best. A unit of work keeps track of everything you do during a business transaction that can affect the database. When you're done, it figures out everything that needs to be done to alter the database as a result of your work. Now that we covered our generic repository, we are ready to review code implementing the unit of work. Let's open up the solution for unit of work from the exercise folder. And in Visual Studio, navigate to the DAO folder and open up the file unit of work. Here I have the class variables for the database context and each repository, faculty and student. Now for the repository context, a new one is instantiated. Each repository property checks whether the repository already exists. If not, it instantiates a new repository, passing in the context instance. And as a result, all repositories share the same context. That's what happens here for faculty repository and right below it for student repository. In part 2, the save method calls save changes on the database context. And again, the unit of work implements iDisposable, so right below it, it disposes the context. Now, another change that I had to do to implement the unit of work is to go into the faculty controller and update the code so that it uses the unit of work. In this particular case, I left some old commented code out just so you could see what it was initially before I implemented it. So for example, originally the repository context had a variable called db, and I commented that out and replaced it with unit of work, which is an instance of unit of work. As we go down the line, for index, you'll see that I'm using the unit of work dot and invoking faculty repository, and had commented out our invocation of faculties in the db context. In details, same thing. Commented out db faculties and implemented using unit of work. Going down the line, for the create method, implemented unit of work. Also, take a look here on line 61. I implemented unit of work and invoked the save method, and then commented out the save changes that was previously there. For edit, similar actions, implemented unit of work, and this applies to both edit functions. This one is for the post, the other one was for get. We continue down the line, the delete method, update that also with unit of work, and delete confirmed. And the very last thing that I did was use the dispose method and did that on unit of work. And that is about it. If I run the application now, you'll see that the standard default visual for an ASP.NET application comes up. We have student and faculty. If I click on faculty, I can come here and create a new faculty member, and Randy Smith shows up. If I wanted to go in, edit it, I can do that, or just go back and not make any changes. If we went to students, it's a similar pattern, similar records, with the exception that we also have a column for year. So that's about it for implementing the unit of work. Whenever you find yourself needing to keep track of changes in memory with multiple objects or repositories, strongly consider using the unit of work to avoid concurrency issues and to keep your code extremely testable. Thanks for watching C# Design Patterns. I've covered a few great patterns to take your code to the next level. If you want to continue your journey with design patterns, check out my other courses, Intermediate Design Patterns Part 2 and Part 3. If interested in continuing improving your unit testing skills, check out C# Test-Driven Development. I'm Reynold Adolph. Feel free to follow me on Twitter at Reynold Adolph and on LinkedIn. Thanks again.